Alright, welcome to the first in a series of tutorials on using Rust to build ESP32-C3 applications. For this first video, we're just going to make a simple Blinky. And I'm going to assume you got through all the development environment setup. So we're just going to use cargo generate to generate a STD project. So we'll name it Blinky. And we do need STD support, latest version, esp-idf. We're not going to do this in dev container. I'm targeting the ESP32-C3. All right, so if we go into Blinky project folder, we can see that cargo generated a hello world for us. So the first thing we're going to need to do is change the cargo.toml file. So first we'll use the latest version of esp-idf-sys. We'll also use esp-idf-hal version 0.40.0, and we're going to use esp-printline version 0.3.1, and point it towards ESP32-C3. Okay, so now if we go into main, we're going to need to use esp-idf-hal, and we're going to need the GPIO, pin driver. Let's see, I think we got IO pin and pin driver. And then we're going to need peripherals. And we're also going to need delay from FreeRTOS. Okay, we'll also use the ESP print line so that we can just use a standard Rust macro for print line, and it'll do ESP specific implementation. Okay, so come down into our main function. First, we're going to get our peripherals. And we need to take it since it's a singleton. Now we're going to make a mutable LED pin object. We need to declare it mute so that we can change the state of the pin from on to off and back again. So that's going to be a pin driver of the type output. And from peripherals, we're going to get GPIO 8. And we're going to unwrap that, which just means do this operation, give me the result. And if it's not successful, then throw a panic. Okay, after that, we're going to do our while one loop forever. And we're going to set the LED pin low first. In my case, that turns the LED on because it's inverse logic. And then we will sleep, we'll delay for a second, 1,000 milliseconds. And then we're going to set the LED high, which in my case will turn off the LED by setting the pin high. And let's see, then we got another delay. Delay milliseconds. Okay, and now we want to print out when we're transitioning. So print line, I'm going to say LED on. I'm going to say print line LED off. Okay. We'll save this, and then we'll compile it with cargo build. Sometimes you have to lock again if you're using Vim. There it goes. This will take a minute. we can look at a few things. So the ESP-idf-hal uses a standard library. There's also ESP-idf-svc, which some of the I think that's networking. I included all these links so you can go review them. Here's for singletons and why we use a singleton, why there's only one object allowable for the peripherals. Here we have our delay. So I included this in the README, but there's two different delays that we can use. One is for under 10 milliseconds. Yeah, that's the ETS one, and then the FreeRTOS timer should only be used for delays that are over 10 milliseconds. So, all right, we can see it's still building. It takes a while the first time. Here's the ESP print line. So it gives you support for JTAG. ProbeRS is something that we can use to debug later on. So this is just better than using the Rust standard library print line. Okay, I guess we didn't need that IO pin, but that's fine. So now we can do ESP flash. My device is at TTY USB modem, and then it's always going to be target, RISC-V, debug. This will be Blinky. All right, and then we can do ESP monitor towards that port. You can see the LED turning on and off. All right, so just that simple. Hopefully follow along, leave any questions or comments below in the video. Thanks.